vortexes because of the buildings. We're going to test that out. We're going to do a few things to think about that theory and maybe even test it. So for starters, let's say this is our vortex. Let's pretend to be Chicago. Let's pretend to be downtown Chicago. So what we're going to do is we're going to stand in the middle and we're all going to be buildings. So you're going to have to be very still. At least don't move a whole lot.
It's gone!
Yeah, looks like our vortex is gone, but if we're really still, we don't do a whole lot. You'll notice that eventually it'll start to come back. It's hard because I'm talking and people naturally move, but ultimately we can see our vortex is starting to form in spite of us. So, let's do a different kind of experiment. Everybody step back again. We're going to make another observation here. Can anybody tell me what direction it looks like the vortex is spinning in? You can just point. Yeah, going this way. Counterclockwise, yes, absolutely. That could be the last one for a while. Alright, so counterclockwise. So, what do you think would happen if we walked counterclockwise, like with the vortex? Go ahead. Might stop? Let's try it. Okay, so let's walk with the vortex in the same direction as it. Alright, ready, set, go. Yes, walk. Try to stay between the lights. Interesting. So it doesn't look like it's having a huge effect. You guys can mess with the levers, by the way. That might actually help us. But I wonder what would happen if we went the other way. So what if we walked in the opposite direction? All right, we're going to switch sides and go the opposite direction. What do you think will happen? The tighter? Interesting. Well, let's see. Oh. That's kind of quirky. What happened? Yeah. All right. So let's go with the vortex again. Let's go in the same direction. Right? We're going to turn around, go the same way. And yeah, if you guys use those vents, if you move them in the plus direction, that'll help it come back a little bit faster. But what we're seeing here is that as we move with the forces, it makes it stronger. As we move against them, it kind of gets in the way. And in this case, it can even get rid of our vortex. It doesn't take a lot to affect the weather or a weather system like this. This is why it can be so difficult to predict the weather. Next time your weather guy gets it wrong, it wasn't necessarily his fault. These are really volatile, sort of temperamental systems. But anyway, thank you guys so much. Oh, by the way, so what we saw here was the way that those forces can work. This tells us a little bit about why we don't get a lot of vortexes in Chicago. It actually has a little bit to do with the lake. There's this thing called the lake effect. But basically, the temperature above the water, the temperature of the